Hello, ladies and gentlemen. Today we are going to take a look at one of the major uses for factoring, and that is to help us find solutions. So we're going to be factoring these polynomials and finding their solutions today. You would want a calculator, maybe that little factoring flip book, or definitely your notes as a reference, as well as to write some of these examples down. So the key question we're focusing on today is how do I use factoring as a way to find solutions to polynomial equations? So how do I use factoring as a way to get solutions to these things, okay? We have these factoring tools like factoring by greatest common factoring, grouping, AC method, difference of squares. Those are all useful tools that we have in our little foldable and we've talked about that will help us factor expressions. Or in this case, we're going to be factoring one side of an equation. So let's take a look at this first one. I need you to write 4 examples in your notes today. They're all a little bit different, but they all use the same techniques of factoring. So notice in this first example, it says factor completely and solve. So we're actually going to find the solutions. I know it's one where I need to find solutions because on one side of the equal sign, I have this 0. Okay, all the terms are on one side and there's 0 on the other. That means I'm ready to go ahead and solve. So since this is 4 terms, we'll use grouping as a way to solve or to factor so I can solve. So let's go ahead and take a look at grouping these first 2 terms together. If I look at just those 2 terms, what can I divide out of each of those terms? I can divide out or factor out an x squared, leaving me with x to the third divided by x squared, or factoring out an x squared leaves me with an x, subtract x squared. If I divide it out of this term, I have x minus 3. Now, what if I group these other 2 over here? Negative 16x plus 48, what could I divide out of both of those terms? I can divide both of those, 16 and 48, by the number 16, and I think I'll divide out a negative 16 here so that I have a positive x, and then 48 divided by negative 16 is negative 3. And I still have the equal 0 on the other side. Now notice what I've created here is this repeating factor of x minus 3, so that's going to be factored out here again. And what else I have is the x squared minus 16 equals 0. Now notice this x squared minus 16, he's still squared. There's a possibility that I could factor him even further. I'm noticing that 16 is a perfect square. That means that I can factor x squared minus 16 into x plus 4 and x minus 4. And that x minus 3 factor, he's just hanging out there, and they're all set equal to 0. So now if I solve each factor, just like we did with quadratics, if I set each piece equal to 0 here and solve, I get one answer of x equals 3. I get another answer. If I set x plus 4 equal to 0, I get a solution of x equals negative 4. And if I set this factor equal to 0, then I get a solution of x equals positive 4. Now notice I got 3 solutions. Was this unexpected, or did I see that coming? Okay, think about that. Let's take a look at number 2 here. We're going to factor completely and solve. So I have 2x to the 5th minus 18x to the 3rd. This has 2 terms, so I'll go ahead and think about them as a grouping together and see if I can divide out a greatest common factor. What can I divide out of 2x to the 5th and negative 18x to the 3rd? I could divide them both by the number 2, and I could also divide out an x to the 3rd from each of those terms. Leaving me with just one set of parentheses here, ladies and gentlemen, I'm going to divide each of these by 2x to the 3rd. 2x squared divide out 2x to the 3rd would leave me with x squared. And negative 18 divided by 2 leaves me with negative 9. So now notice what's in that parenthesis yet, or then that factor. Now I need to think about splitting him apart some more. X squared minus 9, 9 is a perfect square. So I would split that apart into x plus 3, x minus 3 equals 0. I'd have 2x to the 3rd in front still. And now I need to go ahead and set each factor equal to 0 to solve. So now that he's split apart all the way, I'm going to take each of these factors and set them equal to 0. X minus 3 equals 0. I'd solve that and get x equals 3 by adding 3 to the other side. What if x plus 3 equals 0? Well, I'd subtract the 3, I'd get x equals negative 3. What if 2x to the third equals 0? Well, I'd have to divide by 2, and I'd have x to the third equals 0. So what number cubed equals 0? Or I can take the cube root of both sides, and I get x equals 0. So here are my solutions to this polynomial by setting each factor equal to 0. Now let's take a look at number 3, factoring completely and again solving. So notice I have 3 terms here, and I'm noticing that they all have x's in there. Do you see that? Every piece on this side has an x. That's telling me that I should probably try to divide out a greatest common factor first. So if I divide out an x from everybody, leave the x there, and divide each term by x, it becomes x squared minus 4x minus 12. And I still have equals 0 on the other side. So I've just divided out an x. He doesn't go away. He just sits there. He's factored out. And now I look at this thing inside parentheses here, and I say, could I split that apart some more? Well, this is a trinomial. It has 3 pieces. We would want to try to factor that using the AC method. The AC method says, take the number in front of the x squared times the number in the back, or the a times the c. 1 times negative 12 is negative 12. What multiplies to make negative 12 and adds to make negative 4 in the middle? Well, let's start a list here. Negative 12 is negative 12 times 1, negative 1 times 12, negative 3 times 4, negative 4 times 3, negative 6 times 2, negative 2 times 6. These are all ways you multiply to make negative 12. But I'm looking for the pair that adds to make negative 4 in the middle. That'd be these guys, right? So I'll go ahead and rewrite just that trinomial in the middle here as x squared minus 6x plus 2x minus 12. Notice that the negative 4x's in the middle turned into these 2 pieces here because those are the ones that add to make negative 4 and multiply to make negative 12. Now I'll go ahead and group like I do when I have 4 terms. X, what can I pull out of both of those? X, leaving me with x minus 6. What can I divide out of both of those? 2, leaving me with x minus 6. If I divide both of those terms by 2, I get x minus 6. So one factor is x minus 6, the other is x plus 2, but let's not forget that we took this little x out right away in the beginning. We kind of ignored him. He's still there. So now I need to set each piece equal to 0 to get my solutions. X plus 2 equals 0, x equals negative 2. X minus 6 equals 0, x equals positive 6. And x equals to 0, well, there's nothing for me to solve there. Boom, there's my other solution. Okay, so we're factoring, breaking apart, and setting each factor equal to 0. Last one. We need to factor completely and solve. One thing I'm noticing about this one is I don't have the equals 0. So I need to make that happen. I'm going to subtract 14x to the third here to bring him over to be with the other buddies over here. Here we go. There'll be a 0 on this side, as there should be, right? And now if I look at this, I kind of want to rearrange it in the correct standard form order here. So I'd go 2x to the fifth, then I'd have negative 14x to the third, and then I'd have 24x's. That way the powers go down in decreasing order here, and I don't have an x to the third at the end when he should probably be in between the fifth power and the 1 power here. So I'm looking at what I have now, and I have 3 terms, so there's probably an AC method in here. But first I see that they are all 2, 14, 24, and they all have x's. So that's telling me I would want to divide out what they have in common, and that is 2x. They can all be divided by 2x. So I will divide each of these pieces by 2 and an x. 2x to the fifth divided by 2x leaves me with just x to the fourth. Negative 14x to the third divided by 2x leaves me with negative 7x squared. And 24x's divided by 2x's leaves me with 12. All right, so now I have 3 terms in the middle. Now I need to do that AC method again. So a times the c, number in front times the number in back. 1 times 12. 1 times 12 is positive 12. What multiplies to make positive 12 and would add to make negative 7 in the middle? Positive 12, 6 and 2, 1 and 12, 4 and 3. Well, wait, I want them to both add to make negative 7. What if these were both negative? Would that still multiply to make negative 12 or positive 12? Yes, because I need a positive 12, two negatives will do that, and they'll add to make negative 7. So I'll rewrite this middle part here as x to the fourth minus 4x squared minus 3x squared plus 12. Notice how this first term is an x to the fourth and these middle guys are x squareds. Check that out. Normally it's an x squared in front and an x in the middle. But even if there's a 4 power and a 2 power, we can still do that AC method, guys. It doesn't matter what those exponents are. That's what we're breaking apart a trinomial, so that's still a valid method for us to use. It's just that since I'm making negative 7x squared, I need to be careful to label those middle terms with x squared. All right, so now I'm going to group these to factor. What can I divide out of both of those? Oh, x squared, leaving me with x squared minus 4. What can I divide out of both of those terms? Oh, negative 3, leaving me with x squared minus 4, because 12 divided by negative 3 is negative 4. So I'd have one factor of x squared minus 4, that's the repeating stuff, and the other one is x squared minus 3, the stuff I took out. And let's not forget this little 2x that I took out at the beginning, I've kind of ignored. He comes back down, hangs out with the rest, and this is where we're at. We're broken it apart to this point. Now let's look through what I still have in here in these parentheses. I still see some squareds. There's a possibility I could break them apart some more. Now, x squared minus 4. 4 happens to be a perfect square number. So I would split this apart into x plus 2, x minus 2. However, in the next set of parentheses, 3 is not a perfect square number. So I can't split him apart anymore. He's going to stay x squared minus 3. And the 2x still in front. So now let's set each part equal to 0. Because I've taken care of all I can to factor, I'll now set each piece equal to 0. Starting in the front, the 2x equals 0, I divide by 2, x equals 0. There's one solution. What about this guy? X plus 2 equals 0. So x equals negative 2. What about this one? X minus 2 equals 0. So x equals positive 2. What about x squared minus 3 equals 0? Whew, I have to add the 3 to the other side. X squared equals 3. And then I'd have to square root. So I'd get x equals the square root of 3, but don't forget that plus or minus in front. Okay, check that out, people. 1, 2, 3, 4, 5 for the plus or minus. 5 solutions on this polynomial. That means all 5 of these answers would work if we plugged them into the original equation. Both sides would in fact be equal. Okay, so I want to thank you, ladies and gentlemen, for taking good notes and seeing how factoring helps us take polynomials to break them apart, to set each piece equal to 0 so we can find their multiple solutions. Thank you, ladies and gentlemen. Kincaid out.